Right. So what we're going to talk to you about today is basically the character pipeline from beginning to end. So we're going to start with the project selection, project requirements. We're going to go through narrative design. We're going to go through concept. We're going to go through character art. We're going to talk about some materials, talk about rigging and sim, and then we're going to talk about getting all of those items into the game and creating things that you, the players, play as. So let's start with the requirements for characters in Star Citizen. One of the biggest things that we really value ourselves on is that we don't have background characters. So yes, in Squadron 42, you will play as a hero, and there will be background characters. But in reality, you're going to be able to get up close to any of those characters just like you would any of our AAA actors. You're going to be able to interface with Mark Hamill very closely. You're going to be able to interface with Gary Oldman, every character there. And very similar in the persistent universe in Star Citizen, there isn't a background character. You can get up to any of our NPCs. You can get up to any of our mission givers face to face. And we want that. But with that comes a bunch of problems, right? First problem is we scan all of our actors' heads, and we'll talk about this later, but it creates a reason for the fidelity for all of our work to be extremely high. When we start with something that's really good, the performance is really good on our faces, on our animations, and our character assets. Everything has to be high, and you're going to see that later. Allie's going to talk to you about some of our materials, about our hair, about our skin, and simulation with Sean, and everything needs to be a very high level. So I'll show you a quick little level of some of the characters that we've been working on. This is including, I don't think this has any clones. There might be a couple. Some of our characters wear duplicated costumes or uniforms, which is one of the ways we get around not having to make bespoke assets for every single character. So you're going to see some in here. You're going to see in the keynote, I think we are just past, or there he is. There's Clovis Darneely right in the middle. And each one of these is going to use stuff that we're talking about today, because it's all of our character stuff, kind of just showing you the amount of characters on screen that we're handling at one time as well. But let's start with the project distinction. So I want to start with this because it basically, we have different requirements for both of our games. So Squadron has over 250 speaking roles, which alone is an insane amount of work. But it also means that again, there's no background characters, but now we need to make assets, we need to make costumes, we need to make hair, we need to make all these things for each individual character. But some characters might wear multiple costumes. Old Man, for example, wears a couple different costumes. He's going to wear a suit, a pilot suit if he's going to be in his Gladius. If he's going to be, walking around the Idris, maybe he's going to be wearing an officer's uniform. And that's going to be multiple different characters throughout this. The PU, however, has different requirements. We want to make sure that the players are creating their own journey, right? It's not about forcing you on a railroaded path or even on a single-player path. It's about a multiplayer experience. And you're going to be able to do different things with that. But let's start with Squadron 42. So the first thing we're going to jump into is the narrative and design. This is where we start everything. So the who, what, where, when, why, basically, is what we start with. Let's say we have any character. Here we're going to use Steve Colton, Old Man, Mark Hamill, and this is our design brief. This is what we get from the narrative team, and we also get this from the design teams. Let's start with the top. Who? This is the physical description of the character. This is what they look like. Very simple, right? You can see here on the right. So he is male, age 45 to 55. His eyes are hazel. Hair color is steel gray. So you can kind of get a very simple description. And this gives character art and concept art something to start working with. The what? The what is the gameplay component. So what is Old Man going to have to do in the game? Is he going to have to fly a ship? Are you going to have to interact with him ever? Is he going to have to be in FPS combat? These are all things that we need to know for the game. The where and when, this is chapters of the game. This is what locations characters will be in. Are they just on a ship and you never see them again? Are they your wingman and they fly around with you the entire time and you're going to interact with them a lot more? These are all important elements for us to know. And then the why is the brief detailed description. If you played a tabletop RPG, you've probably made pages and pages of backstory for your characters. We have pages and pages of stuff for our characters here. I put a little bit down here, you can see the description and backstory, but one of the lines that's one of my favorites is, "Old man has seen it all. It's his vast sea of experience that makes him an incredible teacher and up-and-coming pilot. Unfortunately, he's not a people person." That alone gives you a little bit of a description of what that character is, right? One thing you'll also notice is we have pictures of the actors. So there's some pictures of Mark Hamill. The picture on the left is actually from the scanning session that we did with him. And you'll see on the picture on the right is, something you would expect more from a press junket or something like that where he's going to be out in public. And so one thing with this as well is, and you're going to see this later as well, is we need to take those scanned actors when they come in, typically as early in the morning, 8 a.m., and they have to go through a whole series of scans and photos and reference and doing that. And sometimes they get a little tired. It's not the most energizing experience sitting there and making faces, Just doing that kind of stuff isn't super exciting. So we need to make them look good, and that's why we add things like that on the right, which is the pictures of kind of a bar for us to hit of what they should look like. In Star Citizen, it's a little bit different. Stories are created by the characters in Star Citizen. They're created by the players. And also we have a whole different element, which is we're going to be going to different locations, right? We're going to be going to different planets. We're going to have different moods. And so you'll see the descriptions on the right is much more simpler. It's about what manufacturer creates these items. It's about where these items are going to show up. And it's more about creating something that's a look or a mood for a place than it is about a character that's going to go on a story and what they need for that story. The only real exception for that is something like a mission giver. But even within that, they're going to kind of fit that mold. So like Miles Eckhart wears stuff from Levski. Clovis Darneely wears stuff from Hurston. But even still, they're going to get something that's kind of a little bit custom to them. So after this, we go into the concept stage. So here you're going to see some concepts for the UEE Marines. And this is basically a scattershot approach or a shotgun approach, depending what you want to call it. And this is where we throw out all different kinds of ideas. So these are all variations of concepts for the same character, right? We know that we want them to be strong. They're in the military. They're some sort of a power armor, right? That's what we want our Marines to be like. So we go through all these concepts, we kind of play around with it, we come up with some fun ideas, and maybe we create visuals for those, or maybe we just created a cool visual and we make up ideas for that, like what that could be. Made an interesting shape, what could this be? And we just kind of go through those. Once we're done with these, we move on to the selects, or that's what I would call them, where we take our favorite elements of each one and we combine it into a couple. Or maybe we liked 10 of the ones that we had. Of the 10, we choose 3, and we combine elements of the 3 to create 1 or variations on that 1. So here you see some front and backs of our medium marine and our heavy marine, both of which have been playable for a little while. And in the middle, you'll also see some feedback. So here you can see it says, maybe that helmet is too bulky. Maybe the legs are too bulky. So on this, we can also start doing feedback as well and doing kind of final iterations to move on before we go to the high poly stage, or also just handing it off to character art. So next is the high poly stage. This is where character art in general typically takes over. And I got a little video here so you can see some of the process of the tools that we use. So what you're seeing here is Marvelous Designer, which is essentially it's a software for making clothes. And the window you see on the right is actually a pattern. So if you've ever done costumes, this is how we create the patterns for the costumes. Excuse me, patterns for the costumes. And then we simulate it onto our body, and it basically creates it. So here we're creating a cape because it's a nice, simple illustration. But you can see it's a very cool, intuitive software that's gotten very popular, and it also adds a really nice level of realism. Here he's creating some seam lines. So he's going through, and he's going to be able to define where those lines are, and then create the compression inside of that so that it'll actually start to almost puff up and feel like kind of a puffy jacket, maybe a padded jacket, a down jacket. And the other piece of software we use a lot is called ZBrush. ZBrush is a digital sculpting package. Basically what that means is you take blocks of digital clay made up of polygons, and you can sculpt them using intuitive tools that are more like traditional hand sculpting than they are like polygon modeling. So here you see one of our artists creating a shoulder pad by duplicating the geometry, shaping it, using some brushes to move it around. And then he's going to start adding some details. So he's masking here, and you're going to see him start moving areas that are not masked to create some extra little details. This is probably character artist's favorite part of the process. It's definitely the most artistic, most, fun part. It's almost everybody's favorite part. And when we get to the end of this, we get to make the final high poly render. So this is actually the Odyssey suit that you guys will have access to in 3.3. It will be replacing the existing Odyssey suit, so it's a little bit of an upgrade. And we're also creating all the material variants and styles that you guys have already seen. After that, we're going to move on to the game mesh. The game mesh or the low poly mesh or whatever. There's a lot of different terms for this. But we basically retopologize, which basically means we draw over the existing high poly with a low poly cage that we're going to apply all the details from the high poly to the low poly via use of textures. So normal maps and different types of diffuse maps, different types of texture maps. And that's where we get all the detail from the previous slides onto what you're actually going to see in game. Low poly is where all of the work is done. It's what you play with. And it's mostly made for things like memory limits. The higher polygon models can be up to millions and millions of polygons, whereas typically, our characters can be around 50 to whatever, 100,000, 200,000, depends on the character. But this is where everything's done. Fortunately, because we're on a high NPC, our budgets are a little bit higher than normal, but we still have to stay within texture memory. So thank you guys very much. This is my part of the talk. I'm going to hand it over to Ali Brown to let you talk about all of our amazing shaders and materials. Thank you.
$50,000 to whatever.
Director of Graphics Engineering. I'm responsible for all the graphics programmers across the company. And for this presentation, I'm going to talk a bit about all the materials and shaders that go into the characters. So, for the first thing I'll talk about is the armor and the clothing. And right from the start, like several years ago, we realized there were some unique challenges on this project. Like Josh alluded to, we have very different needs from Squadron and from Star Citizen. And from this point of view, for the character armor, we have, on Squadron, quality is, everything. We want to get the absolute maximum quality. And when it comes to Star Citizen, normally in an MMO, you would take some type of sacrifice from the quality so you could get the customization and the flexibility to get the scale that you need. But we type of need both of them for both projects. We need absolute quality on both, and we need flexibility on both. So after realizing this, we decided to make some bespoke tech to handle the armor and the clothing, and that's what we call the layer blend shader. So the main concept of this is we initially take a character, and then we'll slice them up and try and find all the areas that will be, say, certain metal, aluminum, or aluminum, I guess, and all the different levers and cloth, and we mask them all out in textures like this, with each colors representing a different type of material. And then, rather than 5 years ago, what you might have done in a game is to make one texture for your entire character. And it would just you'd mix all the materials on that one texture, but there's a limit to how much quality you can get with that. A texture can realistically only be, say, 4,000 or 8,000 pixels wide. So what we do for all of these layers that we've pulled out individually, all these different materials, we model them individually as high-quality layers. So we'll have a high-quality metal, a high-quality aluminum, a high-quality leather, and so on. And then these different layers all then composited onto this character on top of some unique textures for the character, and then this combining of multiple resolutions is really what gets us the quality. The other benefit of it is it allows us to mix together materials in quite a complicated fashion. So here's some Vandal armor. And you can see that the mask here, rather than being in solid chunks, is actually got blends between multiple different materials together. This is, again, just a visualization of where the layers are, and this is the finished product once we've got all them layers blended together. So you can see all the subtle variations in the metal, and you can see how detailed all the individual textures are. And this is the 5 layers that go into that particular armor. And you can see individually they'll look great on their own, but then once they're put together, you really get the top quality. So each of these, oh, sorry, one thing I didn't mention on the last slide, another benefit we get of this is the shader was written in such a way that we can have almost an unlimited number of these layers, and they all get combined together when we actually do the rendering. So it helps a lot with the performance, and it gives the flexibility that we need for the MMO, so we can have the customization and swap out armor for a different color, different style, different patterns, without taking any performance hit. Okay, each of these layers as well, we have some, this is quite a recent addition in the last couple of months, but we can now have different lighting models for each one of these layers, which means we can control how the light will scatter and more closely resemble the different types of materials in the real world. So the first one is called Clear Coat, which is a simulation of a thin lacquer or layer on top of the material, which you can see on the top side. It's a little bit subtle here, but on the right example, it's quite easy to see. But it gives you like a very tight shine on top of it. And here we've added it to this Vandal armor, and you can type of see like it looks a bit more like car paint. You can type of see a very tight highlight reflection from each of the flat surfaces, as well as a broader reflection from the underlying layer. The next one is a cloth. Again, this is pretty subtle to see on the sphere, but if you look on the edges of it, you get type of on the cloth one, you get like a fuzzy highlight on the edges. On a sphere, it's not a very useful example, but when you see a character, you don't get quite new now, but it will be coming in to starting from 3.3. And the last one, which we are only just working on now, is subsurface scattering, which is to emulate more waxy materials, like a thick plastic or other things like that. OK, next is the skin. So we've done a lot of work on the skin. We've had one of our excellent graphics programmers in Frankfurt, Nico, be working on the skin for the last few weeks, or a few weeks ago, sorry, he was working on this. And we've made some real strides recently. So if you look at the top model, top image, that's our skin as it appears today. And down below is how it was a couple of years ago. So there's quite a lot of work that went into improving the quality here. The first one was just following the literature for art, which just basically means we had to get a lot more rigorous in our art pipeline. We had to really look at the physical values of how reflective real skin is and how reflective different ethnicities would be, and make sure that when we're making our textures, we're really following the precise type of reflectance you'd get on a real character. And this made a huge difference in standardizing type of how the characters look and stopped them looking quite so gamey. The next thing was we made some tech changes as well. So the lighting model, which is, there's many components that go into the lighting model, but we improved the subsurface scattering, which is what gives you the type of fleshy red look under your skin where the light is scattering in the epidermis. And we also added some cavity maps, which is a very detailed texture that shows how light reflects in between or doesn't reflect in between the pores of your skin. And that's crucial for when a light reflects off the skin. You can see the shape of the pores, and if you don't have that cavity map, you really don't get the sense of detail. And finally, another interesting thing we have that's different to some other engines and games is our wrinkle blending. So when the character pulls different facial expressions, we have multiple different textures we blend in to type of represent the changes in how the shape of your skin and also the color of the skin when you pull different expressions. Now that itself is a fairly standard technique that many games use. However, what we've done to try and maximize the detail is, because we want these textures to be as high resolution as possible, we couldn't afford to have them all be like 4,000 pixel wide textures for every single variation of facial pose you could pull. So instead, we split it out into 2 different textures. One that handles the micro pore details, the really fine details. And that one stays on when you pull most facial expressions, they stay mostly the same. So we split them out and keep them at really high resolution. And then the type of the wrinkles, how you move and change your expressions, them textures are slightly lower resolution, but allows us to have quite a lot of different wrinkle shapes that we can achieve at the same time. So here's another example of the quality difference, which is quite massive. The top one being the new version of Mark Hamill, and the last one being really quite recent, to be honest, and the difference is pretty massive. See the color, although it's relatively subtle, in terms of color difference, that it just feels more solid, just like it's instantly recognizable. Quick video to show it in action.
Sir?
Who the hell are you? Ease up. You want me to learn your name?
So, cheers. So next up is the hair. So the hair in games is, as you've probably seen, is never the best part of the character. It normally always lets down the characters in games. So the current state of the industry is generally to make what we call hair cards, which is where you make a little flat polygon about 2 or 3 centimeters wide, and that represents, say, 100 or 1,000 hairs. And the artist has to meticulously place these hundreds of individual cards all over the head to try and give a representation of the hair. But it's quite an alien workflow. It's not really how hair is. But it's the industry standard. It's what everyone in the industry generally uses. It's a well-proven workflow. We use a great tool called XGen to generate these cards. And it works well, to be honest, in most situations, but the quality's not there, and it's really apparent in many games. It's not too expensive. Like, we've learned how to make hair that doesn't cost a fortune. It's not cheap either, but we've got by. So the disadvantages of it, when you get close up, that cost does start to increase. So it's because of the amount of layers of hair we have on top of each other, and each of them is semi-transparent. You end up shading, say, 20 or 30 layers of hair, and when you zoom up and you've got a cinematic, that really starts to add up. It's also really time-consuming to build the hair like this, and there's lots of quirks and limitations about the technique, so we have to spend a lot of artist time working around them. So here's an example of old Mark Hamill with the old hair. And you can type of see the light doesn't really reflect off it correctly, and you can type of see it's a bit chunky. So we recently made some improvements to the hair to try and improve some of these problems. So, for example, some of these we'll type of fade out these cards at certain angles to make it hide the fact that these are cards and they're not really individual hairs. We also have some other shader tricks which we use, which is something we call pixel depth offset, which means when you get 2 cards intersecting, rather than them looking like 2 flat pieces of 2 flat polygons, we type of have this variation that gives them that makes their intersection much more complex and more detailed, and it gives the appearance that they are actually hundreds or thousands of hairs rather than a flat plane. We also have the maps that help us vary the difference in color between the root and the tip, and also vary each individual hair strand within the card to try and pick them out, and again, try and hide this illusion that they are actually flat polygons. And finally, we've also started to use TSAA, which is the temporal anti-aliasing technique, and that combined with dithering can help reduce the cost and increase the quality of the hair. So what's next then? So while them new improvements are great, it's not quite enough, and we're hoping to get something better. So we started research a couple of months ago to try and find ways to improve the hair. So the research we're looking at is to try and model the hairs individually as individual splines, and then not turn them into these cards, just keep the original splines. So, and when it comes to the actual shading, all the renderer can actually deal with is polygons. So dynamically, every frame, you turn the splines into a set of tiny little polygons, and then you render thousands of them. And I mean thousands. There's a lot of hairs here. Now, we can't have the real number of hairs on a human head. The hardware isn't quite there. But as a high-end PC game developer, we're type of able to push this maybe further than most people would. So we're pushing it. We're trying to increase the hair count and see how far we can get with this technique, and see how much we can rely less on these cards than the traditional technique. So the advantage of this spline technique, So the quality is just enormously better. You can get much, much better results. I'll show you an example in a second, but it's just night and day. The workflow is also miles better. We get rid of this whole stage of having to figure out how to have flat cards and how to position them. And it's actually the tool I said we use, XGen, for generating the hairs. This is how it works. It generates strands, and the next stage is to turn it into these cards. So we just type of skip that step. We don't have to bother going and doing all that hard work. We can keep the original splines. It also has some other nice advantages where it plays better with some of our other engine effects, like depth of field and fog and glass. So here's the same Mark Hamill again with the newer hair. This is still research in progress, but you can see the way the light reflects and the individual hairs is much, much nicer, much softer, and there's less look like individual planes. There are still some problems, though. The number of polys you end up with in this approach, when you're modeling the individual hairs, it's quite crazy. So we have to do a lot of work to try and make that efficient. That's still ongoing. That's one of the most difficult parts of it, and the memory cost as well, of the number of splines. If you have many thousands of these, you end up with much more polys and much more data than you would have done otherwise with the card technique. We also need to aggressively LOD it. When we have like 3 or 4 lights in the scene as well, we'll have those to be too many polys for us to actually shadow it from the original hair mesh. So we have to make these type of shadow proxies, we call them, which is like a lower poly version of the hair. So that helps us be able to support many shadows at the same time, which is crucial to get the quality. And the final downside is we have to rely on this temporal anti-aliasing we have, TSAA, because without that, we really can't. That's a fundamental part of the algorithm that helps us deal with the high cost of all these intersecting splines, and the TSAA helps soften that result. So we're forced to use that, and that has its own downsides, which are difficult to solve. But if I just show you the end results on a cinematic here.
Sir?
Who the hell are you?
Stay frosty. I'm your new wingman, sir. The name's...
Ease up. You want me to learn your name? Do what I say and live long enough for me to care.
Hope you like it. That's like progress, but we're quite confident we're going to get some really good results from this. And that's my part over. I'll hand you over to the amazing Sean.
Hey, everyone. For those that don't know me, not yet. I know, that was so nice of them, right? Anyways, for those that don't know me, my name's Sean Tracy. I'm the technical director of content here at Cloud Imperium Games. It's basically like a tech art, tech animation, and tools director. Generally on the tech art side, I just want to explain a little bit what a tech artist is. There's a lot of different flavors of tech art, but generally we exist somewhere between Josh and Ali. So Ali is an engineer, Josh is an artist. So technically, we aren't artists, tech artists. It's perfect, right? So basically, we exist in the spot that goes between the two of them. So generally, we're developing tools and we're developing pipelines so that the artist can get all these kind of things in. We try to set those 50 to whatever budgets for the art team, right? Cool. All right. So as I mentioned, tech art rigs, skins, and simulates basically a delivered asset. Generally, what we have to do is bring these characters to life. We need to move them around. We need to skin them up to rigs. We need to put simulation on them. And generally, we need to get them in the game in front of you guys so you can experience all of the cool things that you are seeing up there. So the first thing to kind of talk about in terms of our pipeline is we got to talk about skeletons. Now, what's a skeleton? Now, it's actually just a set of joints. And just to give you an idea, our standard male skeletons has about 170 joints. It's a lot to deal with. But the first part of that process is, hey, is this character male? Is this character female? Is it Van Duel? Is it John? Is it Banu? Is it a creature? Is it a ship? Is it a plant? Is it a cup with ice in it? Those are all the kind of things we have to come up with. So first, we select the skeleton. Now, as I mentioned, some of the skeletons we have, male, female, Van Duel, and there's going to be lots more coming. So we have a whole pipeline behind the scenes that deals with skeleton updates. We have somewhere between, I think it's about 60,000 animations right now. So if you make a single skeleton update, an animation really is just a bunch of transforms or a bunch of rotations that are all keyframed. But as soon as you change those joints, you'd have to batch process that entire 60,000 kind of animations. So we work on some nice update pipelines that make that not having to be the case. Now, after that, we get to skinning. So what is skinning? A lot of people, when they hear skinning, they're like, oh, that's the texture. That's the material. To us, that's not at all the case. Skinning is actually weighting certain vertices of the characters to the bones so that they move at a certain rate. So when I move my arm, we've got this vert skinned into my upper arm, so as that moves the vertice. So it sounds like a pretty easy process, but actually when you get some really complex pieces of armor, some really complex characters, this is actually pretty tricky to do and pretty tricky to make look real. So this is a big part of a tech artist's job. So then once the skinning and rigging is done, we'd move on to simulation. But first, I want to show you a little bit of the actual process that we go through for skinning. So here we've got a piece of armor. This is actually one that I showed in a cloth talk a little bit earlier. It's one of the Hurston Security with some brand new cloth text that we're using. And you can see that the poly counts are whatever, right? So they're pretty high, and it means we have to deal with every single one of these vertices. This is why a tech artist actually really cares about that budget, because every single vert they add is a vert that we have to skin, right? And you can see that it gets pretty damn granular. Now, we can start off pretty basically where we actually project from our naked male, from our base male, onto the armor, but then it's going to just look like a wetsuit or something that's literally attached to the skin. And this is where the trickery comes in. We've got to blend weights. All the different colors are basically different weights, different bones that are on that particular one, how many weights there are on it, which bone it's attached to. And then we can have really hard things that are like along the spine. If we're moving our shoulders back or we're moving our arms up, that's just another level of complexity that we have to deal with. So what they do is they touch up the skin from the projection, and then we have to run a ROM on it. What's a ROM? It's a range of motion. So we have an animation that we can just load up really quickly, and we can run them through all their paces, literally a running pace or walking, or we even have one that actually goes through a huge range of motion. Basically, everything that a game character could do, and we even go a little bit further with some of this stuff because, of course, we have things like VoIP and runtime ringing, so you can sometimes do things that we're not necessarily expecting. So they polish those up, we do the ROM, and then we move on to simulation. All right, so dynamic simulations. What's a dynamic simulation? Dynamic simulations are things like bubbly bits that are all over the characters. Generally, these kind of bits make characters look a lot more next-gen. It gives tons of secondary motion to animations. So my shirt shouldn't just stay rigidly attached to me like a wetsuit. As I move around, that should be loose and move separately to me. The problem with that is that though we can simulate all kinds of attachments, you would usually have to make bespoke animations for those attachments. So instead, we use the physics system to kind of make up for this. So we can simulate all different kinds of attachments. You guys are seeing it all over the game already. You've got weapons, you've got grenades. I don't think we have earrings in yet, but we'll have earrings at some point here. Maybe not for players, maybe for... so we got earrings, we got hair, we got all kinds of stuff. Josh kind of gave me a... That's okay. All right, and these require joints. And like I was talking about before, we've got 170 joints in the base skeleton. But if you need joints for these simulations, what the heck are you going to do? Because now we have a bunch of different outfits that we have to put on, but you'd have to then carry all the joints around on the base skeleton, so every single possible combination of every single possible attachment with every single possible simulation on your base skeleton, we can't do that. Now, that was kind of an old school way of doing things, and I've worked on games that was the case. You have to carry those joints around. Luckily, we have a cool system called skeleton extensions. So basically, this is a set of joints that I can attach. A great example is like a magazine, or even like the trench coat is a great example. The trench coat has a whole bunch of joints, and I think it's another 100 or so joints just to do the sort of cloth simulation to it. Again, we can't carry that on the base skeleton, but with skeleton extensions, we attach it, and then we extend the skeleton at runtime. And then when you remove it, we clean those joints right back up. Now, provided they're all physically simulated, this is actually pretty straightforward to do. I say that as being not the programmer that wrote it. So, This is preferable to skinning, as no specific animation is required. So basically, nobody has to go in and animate this thing. That just works. The animator might have done this run cycle 2 years ago. That's fine. If I put the cool jacket on him, it's going to move exactly like you expect, no animator input whatsoever. So I refer to this a lot of times as runtime rigging. So let's take a quick look at that. I might have to loop this video once or twice. So this was actually Silas's outfit in one of our commercials before. And actually, not to get you to look, but at the bottom of the jacket, you can see that actually it simulates quite more realistically on the right-hand side. Now, I'll loop that video back again just so you guys can see that a little bit more. So again, if we had to if we had to animate this specifically, that would be a bit of a problem. But it's subtle stuff, I realize, but that matters to us, and it absolutely matters to Chris. So you can see the jacket on the left is almost attached to him, right? This is like a wetsuit. This is full skinning, no simulation joints. And then the one on the right has some nice, just some simple bone chains, nothing too crazy, just to give it that flow that you would expect out of clothing. So we'll be taking this to the next level. And if you saw the cloth talk a little bit earlier, you'll see kind of where we're taking this kind of stuff. All right. So moving on from that, I want to show a little bit of a kind of a highlight reel on how these guys go about actually marking up this runtime rigging. So we've got two different tools that we use. Generally, we use Maya within as a DCC and setting up the joints themselves. But then we also have a bunch of in-engine tools. One specifically called Character Tool that the tech artists use day in and day out setting up these simulations. And I'll call out some of the ones that we actually use. There's a lot of different types. So here, for example, is Batiglia's leg, or basically the cybernetic leg that we showed in, I think, an ATV just really recently. So this uses a ton of runtime rigging. You can imagine that we wouldn't want to rebuild a whole skeleton just for this. So there's a lot of aim constraints within this one. And what that gives us is a lot of hydraulic sort of feels. And this is all happening at runtime, so there's no specific animation made for that one. Same sort of thing, this is the heavy slaver arm. There's a big piston that twists. So that actually needs an aim constraint as well as a twist constraint. Then we've got ties. So, and I realize this stuff is subtle, but if it's not there, it just doesn't look right. So this one is a pendulum chain of, I think, about 10 to, probably about 10 joints, maybe a few less. And you can see there's little physics on them. These are, we call them lozenges. They'll actually impact each other, or they can collide with the environment. And again, that gives that secondary motion. We can't go back to an animator and say, we made a tie. You have to do 60,000 animations again. Steve Bender not be pleased at all. So here we kind of hidden this asset a tiny bit just because it's a bit of a Squadron asset. We don't want to give too much away. But we have to do the ponytails. Same sort of idea. It's a pendulum simulation. And here they're inside of Character Tool, just actually turning them on and turning some of the debugs on with them. And usually when we set up these pendulum simulations, what we deal with is weight, range of motion, so how much on a pendulum this can actually move. If we do it on a weapon, we use a half cone kind of technique, so it can be flat against the back. But you can see, even for stuff as subtle as a ponytail, this can get pretty busy. So this is a bit of a grayscale. Again, we just don't want to give anything away here. And again, this is in slow motion, so keep in mind. So here is, I believe this is the heavy slaver as well. And this we kind of have, I got no better word for it, kind of a skirt, sort of loincloth kind of thing. It's really, it's heavy. But you see there's a lot of simulation joints to pull this one off. We're going to turn on the debugs to all of them, and you'll get kind of an idea that even something as subtle as that, back and front, it's some work to get this polished and working quite right. So huge amount of respect for our tech artists there. Now I realize this is a bit weird, just the legs walking around, but again, you see the simulation working quite nicely. Cool, I think that one kind of does it there. Cool. Okay, so now that we've done the skinning, we've got the skeleton, we've skinned it, we've simulated it, we have to get it into game, do something with it. Now, We've kind of talked about this a little bit, but our characters are made of items just the exact same way that the ships are. So we actually use the exact same system of item ports. So characters are just a set of items. The body is an item, a shirt is an item, the head is an item, even the eyes and the teeth are items. All these items have unique components on them, and this is kind of the whole reason for this is that we need things like additive components, and these are gameplay components. These are sets of code that aren't just restricted to a character entity. It's literally just the item carrying it. So a good example of this is like armor rating. So I might have an armor rating of 5 on my torso and 2 on my legs. When I put the legs on, I have 2. Once I put the torso on, I have 7. So those add up kind of together. And there's a lot of different components on it. We also carry some sort of hiding and showing logic, which I'll talk about a little later. We call it zone culling. Now, these are all attached within a certain hierarchy on item ports, and I'll talk about that in a second. So one of the things that happened was as Star Citizen was starting, we had a lot of assets. And generally, if you're going to make a sort of modular character system where people are going to wear multiple layers of clothing and interchange them between each other, there's a really important thing that you need to do, and that's to follow the exact same topology from your body all the way up. And that means literally the same polygons all the way across, regardless of what kind of outfit it is. This wasn't the case. When most of us came out, we had a lot of assets already. So basically, that decision was already made. The reason this is a problem is during deformation. So if you can imagine I have a long jacket on, and I bend my arm rather. If the body topology, so the actual polygons of it, is different than my jacket topology, I'm going to get clipping every time. I'm going to have the elbow come through, and there's no amount of skinning that you can do to fix that because they're just literally too different. So I might have 2 edges here to deal with, and then 3 edges on the elbow. So that third edge is always going to go through because I have no other control. So how we solved that was by just not having the problem. We said, let's just call that stuff out. So we call out the polygons on lower layers. But now we have the problem of layering. So as we go up, we have 3 to 4 different layers that can be on top. Sometimes you want to show a shirt. Sometimes you want to show a jacket that still shows the naked body. Sometimes there's a lot of built-in logic to this, and that's actually housed on the components. So I want to kind of show you how this kind of works. So here we have a very fit male. And as the shirt's attached, basically we just chop the asset in half just to show you what's happening below. We actually call out the entire chest, and then we call out the upper arm. And you saw on the previous slide, we have, I think it's 32 zones. I might get that wrong. But it's between 30 and 40 zones right now that we can call out, and that's all marked up within it. So again, the upper arm is gone, the lower, the bicep sort of area, and the entire torso. So we do that for t-shirts, long sleeves. So on a long sleeve, all of a sudden we hide a couple more zones. And again, we just don't deal with this similar topology problem. Also, we get a little bit of performance back too, which is good. So there's another sweater here. Then full t-shirt back on. And now a jacket layer, which makes this a little more complicated. So now that we've got the jacket on top of a t-shirt, we actually have to add those layers and that logic together. So the t-shirt is hiding all the chest and upper arm, but it would have left the lower arm. Now that we have a jacket on the higher layer, then we continue to hide the lower arms. And I realize it sounds subtle, but there's a lot of internal logic that actually has to happen within there. Just, again, some rules that are set up within the items. So it's really hard, but at some point we had to make a call on whether we were going to let you guys kind of go with the Fabio jacket kind of thing, where we have a jacket with no shirt underneath. Chris said yes. Okay, it's cool. All right. Then he's right back to it. So that gives you an idea of what we're doing with zone culling anyways. So I talked about the items. Ultimately, all of these items come together in a file we call the loadout. So this is a loadout is literally just a snapshot of a hierarchy of items, and they all depend on each other. So you can't attach a head without a body. You can't attach eyes without a head. You can't attach glasses without eyes. You can't attach hair without a head, without a body. You can't put an undersuit on without some clothing on the body. Like, it's all hierarchical in that sense. And the loadout literally is just a snapshot of that. you players, when you're playing and you're working with your Mobi-Glass, setting your loadout, you don't really see the hierarchy, but you are actually just adjusting your own hierarchy of a character. Now, we have to set up hierarchies for NPC characters, so we have a little tool. It's a little less flashy than a Mobi-Glass, but we have our own internal developer tool called the Loadout Editor that the designers and the artists can actually put all this stuff together. So I want to show you kind of some of that in action and how we do that. So I'll kind of go a little slow on this one. We've got, first, he's actually added the body item on, and I realize the UI is dark. He likes the dark UI. Power to him. Thanks a lot, Brett, for making the video. Now, he's attached the body, and on the body, we have a whole bunch of ports. We got the armor undersuit port. We got clothing feet, clothing hands, clothing legs, torso 1, torso 2, and the head. So next step, we're going to add the head. So great, but the head has no eyes, so maybe we got to add some eyes. Then we add some teeth. Then we add some hair. Then we go to clothing torso layer 0, and we add sort of an undershirt. So our torso layer 0 is kind of stuff that touches your skin, and then torso 1 is above it. So we put some shoes on. Now, we talked about the zone culling system, and what's kind of interesting is that we call the body as we attach clothing, but we kind of have the exact same relationship when it comes to armor and undersuit. So if you can consider that a naked body is to clothing the same way an undersuit is to armor. So that's the exact same sort of structure. It's just all additive to the other hierarchy. So you'll see that as soon as we attach the undersuit, oh, that already happened anyways. As soon as we attach the undersuit, we have to hide all that clothing. So that's all already called out, and that's on the highest layer. But now we have to attach some torso items, attach a helmet, and we're still doing that same kind of culling all the way down onto the undersuit. And then we can even add some weapons. I think we attached a paw there, some grenades, give some magazines onto them. And then in the end, all we do is we save that loadout, we load that as an XML directly on an animated object, and there's your character doing that. And you can also just, for the developers anyways, we load the loadouts pretty directly on the players if we have to, and these kind of things. So it's quite nice. Cool. So that kind of gave you a really good idea of, like, literally start to finish. We go from concept all the way down to loadout implementation. And as you can see, there's a lot that goes into this, and especially the stuff that Ali was talking about. There's so much subtlety in a lot of things that we're doing. Like, we were really happy with those faces. Maybe, again, I was actually really happy with the Gary Oldman stuff 4 years ago. But as time has progressed, as new things have come online, we can push it further and further and further. And again, there's a lot of subtleties. Now I want to talk about some future things that we're going to start looking into, which is pretty exciting. So creatures, that's a big one. We kind of played around with a sandworm. Cool. We played around with a xyphopod. Cool. But now we have Hurston. We have savanna biomes. We need to get some life into them. So that'll be a really fun thing to work on. Really stick around for the next talk because there'll be a little bit on this in there, some body variations. So that'll be interesting too. We can't all be buff and perfect like that guy is. So we've also got more aliens to deal with. And by aliens, I mean whole alien races. So we have the Banu and the Jian. That's going to be super interesting. We've got procedural character stuff. So I talked a little bit about these loadout hierarchies. And actually really nice to work in those kind of hierarchies is you can make that procedural, I don't want to say easy, I keep saying easy. You can do it in kind of a straightforward manner because it's a whole set of rules already that's built into the system. You just ask it to do certain things. Then again, stick around for the next talk as gene splicing will be a thing very, very soon here. And then finally, as you've started to see, that we've started to implement these cybernetic limbs. So it's only a matter of time until we get the Death of a Spaceman stuff moving along, and we get that to you guys as players. So hopefully you guys found this talk pretty interesting. We want to have some big special things. We had a lot of help making this talk, and we get a lot of help day to day between all the different departments. Characters take a lot of people to put together at this level of quality. So huge special thanks to Andrew Hernando, Brett Morris, Shane Hessler, Chris Von Camperno, Corey Johnson, Erica, I don't want to mess it up. Erica, thank you, For Stefan, Gage Hallman, Gun Park, Jeremiah Lee, Marcy Lee, Milan Paycheck, Tyler Young, and of course the rest of CIG. And mostly you guys. Really, I'm always so happy. People come up and say thank you to me, and it's us that should be thanking you, because you guys are letting us do this work. This is our passions. I could be doing other jobs. I could be working on Barbie's Funhouse Adventure or something, but you guys let me work on this stuff. So thank you, guys. Thank you.